Good evening once more. So we start with today's class. As mentioned earlier in the group, we'll be looking through probability, concepts of probability. So just help me confirm, at this point, have you learned probability with Mr. Collins? At this point, have you covered it already?
I think we started, yeah, partly. I think we covered part of it. I think obviously we still have struggles here there, but yeah, he introduced the topic.
Okay. So my role this evening would just be to restate one or two concepts that he had already introduced. Then we'll do some practical questions, because the key with probability is not maybe just to learn the concepts, but I believe that one of the quickest ways in which we could learn probability is also being practical with what we have learned. So I'll just quickly go through some of the basics, then we'll spend, I think, a great amount of time doing a tutorial together, where we just attempt questions here and there, and where it may not be clear, then I'll just get to explain the concepts and as to why we might be doing what we may be doing in order to arrive at the answer for the specific question. So now, just a quick recap, then I'll share the screen where the question is, then we start from there. So we're looking at probability concepts, right? We're looking at probability. So now, probability, of course, by definition, is simply defined as the chance or the likelihood of something happening. That is how we have defined what probability is. Why you want to know the likelihood of a particular event. What is the chance that it will occur? For instance, what is the probability that tomorrow it will rain? What is the probability that tomorrow will be a Wednesday? So we want to understand the likelihood of something. So now, another key thing that we ought to understand under probability is also being able to appreciate or understand what each probability as an answer that we get, what it means. All right. So we know that probability can never be greater than 1, but could only be less or equal to a 1. All right. So we could never have probability that is greater than 1. The furthest probability that we could ever have at any given time, it is that which equals to 1. So now I want to explain on what various probabilities mean. So for instance, if meaning that the scale ranges from 0 and it goes to 0.1, then all the way to a 1. So I'll just draw a line here. So this will be my 0.5. So meaning that out of all the answers that you might ever get, as long as it is probability, it can never exceed this particular range that I've explained, unless where you are expressing your answers as percentages. So if you're expressing your answers as percentages, then I would say that your answers cannot be more than 0. I mean, they cannot exceed this particular scale of 0 to 100%. So meaning that at no point will I expect to have an answer which is 120%. That's if you're expressing your probabilities with percentages. I can't have such a scenario. At the same time, if we're expressing probabilities in form of decimals, we can't have a situation where this exceeds 1. So that's that. So now the meaning. So now an answer of 0 simply means that the likelihood of something happening is impossible. It's impossible. Like for instance, what is the probability that tomorrow will be a Thursday? It's a 0. There's no chance that tomorrow might be a Thursday, because we know with certainty that tomorrow is a Wednesday, all right? So if it keeps on building, meaning that it changes now from impossibility, any answer that is between 0.1 maybe up to 0.4, we're saying that, okay, there's a possibility, or it is less of a possibility, but there's still a chance that it might happen. Then 0.5 all the way to 1, we're saying that, okay, there's most definitely this could happen. There's a good chance that it could happen. Then if it is an exact one, then we are saying that we are confident without a doubt that this particular event that we are investigating will happen. So that's the key thing of probability, understanding its concept. So now I'll quickly go through what the ultimate formula is under probability. So whenever we're dealing with probability, we always say that probability of any given event, okay, the probability of any given event, let's say event A, all right, is equal to the favorable outcome divided by the total number of outcomes that A could run through. So now this is the formula at its basic, but of course, depending with the situation at hand, we might need to do 1 or 2 steps, as you will see in the tutorial that we have for today. But at its basic, if you want to get probability for any given value, we say the favorable value over what total number of outcomes. For instance, if you wanted to know what the probability is of maybe getting a 3 if you roll a dice, probability of getting a 3 if you roll a dice, all right? So favorable outcome of rolling a 3, there's only 1 3 on a dice. So meaning that becomes 3 out of what? 6, where we're saying 3 is the favorable outcome and 6 is the total number of outcomes, because the only possible outcomes that are there when you roll a dice, they're equal to 6. So now there are other variations that exist when we are computing probability. Okay, that is when we are dealing with the addition of probability and the multiplication of probability. So that is what are the rules that we consider when we are adding probability. All right, what are the rules that we consider when we are adding probability? So now, in order to know which events we add or how we add, we have to understand this particular concept. Okay, so if you are dealing with events that are called, which are referred to as mutually exclusive events, all right? If you are dealing with events that are mutually exclusive meaning that if one particular event occurs, it does not affect, or rather, if we're saying that events are mutually exclusive, if events are mutually exclusive, we're simply saying that the occurrence of a particular event does not in any way affect the event of B. So therefore, event A and B, we will say that they are mutually what? Exclusive. All right, so meaning that A could exist or could have its own existence without having to rely on what the existence of B is considering. I'll give you an example, all right? Right now, I'm in the copper belt, and you who's listening, you are in a different place. So meaning that you and I, we are mutually exclusive events in the sense that my being here does not affect your being there, all right? So meaning that we are different, all right? So those are mutually what? Exclusive events. So therefore, mutually exclusive events, the probability is given by probability of A or B, all right? Probability of A or B is equal to the probability of A. Probability of A plus the probability of B. Okay, meaning that event A is not in any way affected by B. Then under addition, so now what if we say, okay, what if event B maybe somehow is affected by A. So now in that case, meaning that, and by the way, oh sorry, so in that particular case now, if events are not mutually exclusive, but yet we are adding, we say that the probability of A or B, that's if now they are not mutually what? Exclusive, is equal to the probability of A, all right, close brackets, plus probability of B, close brackets, minus probability of, not that, we say probability of A intersection B, all right? And as I've made mention, I'm hoping that you would have already gone through this by now. So we'll just now do practical questions on how we'll be applying this. So now at this point, let us just look at some of the questions that we have. Then again, I'll go back to some of the other rules that we may need to consider as we solve the question. So let me share the screen for our tutorial for today.
I think so.
Okay. Could we confirm if we're able to see the screen? Hello? Are we able to see the screen?
It's still loading on my end, so I can't see it yet.
Okay. Good to see it. Are we able to see?
We can see it now.
Okay, all right. So we'll be attempting these are questions that are based on probability. So we'll just be attempting them, and we'll be explaining through them as we make progress. Okay, so now we are told to say that given the probability that a random selected student in a class is female is 56%, determine the probability that the selected student is male. So now remember, in my preamble, I made mention to say that in any given situation, all right, in any given situation, probability, after we find the probability, if I am adding all the probabilities that I have computed at any given time, the idea is that I have to get a total of a 1, okay? So I know that in any given situation, I have to get what? A 1. So if I'm getting a 1 as a total after adding all the probabilities, the question would be that if I gave you 40, if I gave you, let's say, 0.4 as the probability for one particular event, it simply means that the other probability should be the value of what? 0.6, such that if I add the two probabilities that I have here, I should have the answer of what? 1. So these are key concepts that you need to know in any given situation, as they will help you to solve such questions like number 1. So now, given the probability that a random selected student in a class is what? Female. So we've got two events here. So we could say probability of, we've got the probability for female, right? We've got probability for female, which is recorded at how much? 56%. So I could say 56%, or I could say 0.56, depending with what I want to, see at the end of the day. So let us say I'm using a decimal, all right? I convert my percent there into a decimal, all right? So that would be 0.56, right? Then I'm being told now to find the probability for it being what? Male. There's a question mark here. I don't know what the value is. So now, because I understand that probability, so if I added the two probabilities here, I should have the total of what? 1. So meaning that the probability of male in this case, probability of male in this case will be equal to 1, all right, will be equal to, probability of male in this case will be equal to 1 minus the probability of female. Are we good with the way I've expressed it like that? So meaning that would be 1 minus 0.56. All right. So if I found the difference there, (1 minus 0.56), I get 0.44. So meaning that's how we would attempt question number 1. Are there any questions? Are there any questions so far? Okay, that is clear. So meaning that's how you'd handle such a question as number 1. So now we look at number 2. All right, we look at number 2. Number 2 says, a customer survey asked respondents to indicate their highest level of education. All right, a survey asked respondents to indicate their highest level of education. The only 3 choices in the survey are high school, college, and other. So we're saying if 31% indicated high school and 49% indicated college, determine the percentage of respondents who choose other as category. So now I want us to be a bit interactive, all right? I want us to be a bit interactive. So at this point, I know at this point we're all able to see the questions. So let me how would we approach this one? I'm going to pick at somebody, maybe just to give us their comments on how they could approach such a question, because here we're just trying to consolidate on the principles that we have already learned. Okay, all right, so let me start with Hope. Hope, good evening. Could you come on the mic? Hope, good evening. Are you able to come on mic? Or maybe if somebody has got an idea of how we can approach question number 2, can I get their feedback on how we could do question number 2?
Yes, like we said, the overall, the total sum of the probabilities adds up to 1. If it's in terms of percentage, it adds up to 100. So all we need to do, since there are 3, all their probabilities must come up to 100. So we have to add the 2 percentage probabilities that we have, then subtract from 100. And that will give us the percentage probability for the other.
Exactly.
Submit.
All right, that's as accurate. So 1 and 2 are more of the same kind of approach, where we are using the understanding the probability can't exceed either a 1 or 100%. So we simply add what we have been given, then subtract from 100 to get to what the probability for the other category would be. So meaning that will give us the answer. So therefore, probability for the other, in this case, other category is simply equal to, we say, so if we use 100%, we say 100%, all right, then minus, then we add what we have been given. We've been given 31 plus 49. So that becomes 31 plus 49. So the total that we get there, then we simply subtract that from 100% to get the probability. So meaning the probability there becomes either 20% or 0.2%, depending with the format in which you're expressing the final answer. So that becomes our answer as either 0.2 or 20%. Okay, so we could go to question number 3. So now question number 3 says, the following data set shows the results of the survey asking families on how many cats they own, all right, on how many cats they own. So we have a number of cats, and as we had made mention, probability should add up to a 1, all right, it should add up to a 1. So that being the case, meaning that we'll say we have the number of cats as 0 all the way to 4, meaning the probability of somebody owning 0 cats, they've got the chance of 30% of 0.30, and it goes on like that. So question number 1 says now, determine the probability that a randomly selected household in the survey had fewer than 2 cats, all right? So now here, what are we looking for? We want to find the probability that a particular person had what? A particular person had fewer than 2 cats. Okay, that's the question. So now here on the left part, we've been given the number of cats. So I want to pick on those values that have got fewer than 2 cats. So if I want to pick on values that have got fewer than 2 cats, we'll say probability, where's my marker? So say probability of picking two Sorry for that. I had a drop in my network. Okay, so we were looking at question number 3. So the following data, we have read that question. So determine the probability that a randomly selected household in the survey had fewer than 2 cats. So now on our left category here, it's giving us the number of cats. So the only thing that we have to define is to define what will exactly cover the cats that are fewer than 2. So anything that is fewer than 2 will include probability of 0 and probability of what? 1. So therefore, probability, we're simplifying the probability, that is the probability of 1 and what? And 2. That's what we'll be looking for. All right, probability of 1 and 2 because, sorry, of 1 and 0. Why are we looking 1 and 0? Because we're being told that that should be fewer than 2. So anything that is fewer than 2 includes only these 2 values. So therefore that will be 0.30 plus 0.36. All right, so meaning that will give us a total of that is 0.66. Are we all good? Are we all clear so far, so good?
Yes.
Okay, all right. Then number 2 says, determine the probability that a household in the survey had 2 or fewer. All right, had 2 or fewer. So now here, pay attention. Here it said that in the survey had fewer than 2 cats. So this was explicit and it was concise in that we wanted to have anything that is fewer than 2. But in this case, we are looking at probability that it had 2 or fewer, right? It had 2 or fewer. So if we're looking at 2 or fewer, meaning that I'm including to the very same answer that I had, I'm simply also including what? The probability of 2, because it's asking me to start from had 2 for anything that is fewer. So we already have the answer for the probability of it being few, which is at what? 0.66. So therefore, that will be 0.66, which is coming from it being fewer, plus we also add 0.25 to get that particular answer there. And our answer that we get there, we get that is 511.91. Okay. That is how we would solve such a question. Right. Then number 3 says, determine the probability that a random... Yes, please.
Just a quick question.
Yes, please.
That's a quick question before we move on.
Yes, please.
So in terms of the actual expression for the probability that they are fewer than 2, is it probability that is less than 2?
Yes.
If we are to use the sign like the less than sign.
So meaning
It should be less or equal.
For the first one, it will be
then the one
less.
for...
So for the first one, this one, right? This will be probability that it is less than 2.
2.
Less than 2.
Then,
So
then the next one, less or equal to 2, huh?
Exactly. Because also including 2. Yes. Then number 3 is looking at determine the probability that a randomly selected household from the survey had more than 1 cat. All right, had more than 1 cat. So we need to say that anything, or rather any individual that had at least 1 cat and more, that's what we're looking for. So we need to say that it is simply, we could do it in 2 ways. You could simply get the total and remove for the guy that did not have any. That's in the first way, because we're saying that the probability that at least we're saying that the probability, just a moment. We're looking at the probability that the randomly household from the survey had more than one cat. So any person that had at least more than one cat should be part of this computation. So meaning I'm simply adding 0.36 plus 0.25 plus 0.07 plus 0.02. Alternatively, and easiest way of how I could arrive at the answer, since I know that all the probabilities starting from that, the person who owned 0 to 4, their answer is 1. I could simply subtract 1 minus 0.30 to get the probability that at least an individual owned at least or more than one cat. Does that make sense?
Just repeat.
Okay. So here we are saying that in the probability that a randomly household from the survey had more than one cat, right? Meaning we're looking for the people that had more than one cat. So we have to say that from here to here, they had how many cats? This guy had 0 cat. This guy had 1 cat. So we're saying that anything that is more than. So if it is more, what am I looking at? So anything that is here.
You are looking at the probability from 2 going up.
Exactly. So that is 0.25, 0.07, 0.02. Or conversely, what you could do, you could simply subtract the addition of these two. Remember, we had this computation already in the first part where it was fewer. You could simply say 1 minus that to get the addition for that which is remaining. You'd still arrive at the same answer. Is that okay? So therefore, this would be expressed as follows.
Okay, thanks.
Probability that more than one cat. So we can say greater than 1 of x being greater than 1. All right. So that is the probability of 2 plus probability of 3 all the way to 4. Then we simply add the numbers that we had, the probabilities that we had there, which is 0.25 plus 0.07 plus 0.02 to get the answer there. Are we good with that one? Any questions? Okay. So the answer that we get there becomes 0.25 plus 0.07 plus 0.02, which gives us 0.34. 0.34. So that becomes the probability 0.34. Or in the other way that I'm explaining, remember to say that we already had the answer for the first one, right? Which was at 0.66. So you could just say 1 minus 0.36 plus 0.30. Also, that will give you 0.34 as the probability. So it depends with which one you want to use. Either way, the answer will be one and the same. Question number 4, it says, a recent survey found that 62% of the households surveyed had internet access. Okay. 68% had cable TV and 43% had both. All right, had both. Determine the probability that a randomly selected household in the survey had either internet access or cable. All right, had either internet access or cable. So now, I want you to pay attention to these two words. So now, there will be, so if you look at the word either or, all right? So whenever either or has been used, the formula that you're using for probability, it is simply the probability of A or B, okay? if you have just seen either there, it's equal to the probability of A plus the probability of B minus the probability of A intersection B. All right, whenever you just see either. But if it was just a single O, in that case, we would say probability of A plus B without including this particular part, which shows that the same values that are in A are also part of B to some extent. So therefore, meaning that this shows dependency and that the events are not mutually exclusive. Okay, so now we know to say that found that 62% of the
Please
household.
repeat that again.
Okay, on the either and or
Yes.
okay. So I was saying that just something to help you to quickly go through the question 9. So if you've noticed to say that the question is asking for had either or, either like the way they've used either internet access or capable, meaning that you are dealing with events that are not mutually exclusive. All right, meaning the events are not mutually exclusive. And if events are not mutually exclusive, you use this formula that I've given you here. But if a situation where maybe we had maybe O only used as a singular and in the statement there is no either at any point, we are to assume that the events are mutually exclusive. Therefore, we use probability of A or B likewise, only that it will be with the exclusion of what? A intersection B. So meaning I would only be focusing on what? Probability of A plus B. That's what I'm explaining. So pay attention to such words as you.
That's when it has O.
When it was on, assuming like the way I've marked this one out, if we only had O as a singular, right? So in that case, meaning that you're using the events are mutually exclusive. So therefore, you'll be using the second formula here. But if either or means that there's the values are dependent in that the values that are in A are also in B, and I'll get to prove it as we, or rather get to explain it as we look at A. So, but just those two terms, not if either or are used, just know that you are using this formula there. If only I have O, then I am using this particular formula in my second part.
Okay.
All right. So having established the formula that we are using, so now let us try to fill in the formula to answer the question. So a recent survey found that 62% of the households surveyed had internet access. 68% had cable TV. All right, 68% had cable TV and 43% had both. Okay, so now the first thing that we have to do here, we need to code our work. All right, so we'll say, okay, let us assume that the event A is being represented by those households which have internet. Okay, so if I use A, I mean that these guys have got what? Internet. If I'm using A, then if I use B, what I'm simply saying is that they've got what? Cable, because these are the two things that I have been given there. So meaning in that formula that we had here, where I put A, I'm referring to internet. Where I put B, I'm referring to cable there. All right. So now we are told that 62% of the household had what? Internet access. So meaning that the probability for internet access, all right, for internet access is given by what? 62% based on the question. That's why I'm getting this from, right? And we are being told that 68% 68% had what? Cable. Okay, 68% had cable. Okay, and we are being told that actually 43%. So now let me explain this concept. So when they were trying to count to understand those that had internet and those that had cable, all right? So this is how they counted. So they started by counting those with internet. They counted 1 up to 62, okay? Then they went to cable. They kind of went up to what? 68. But now, at this point, when they were counting for those that had cable, it was found that certain people could have owned cable and they also owned what? 48. They also owned what? Internet. Okay? Have we heard that point? Meaning that those that owned both of these items are the people that have been represented in this particular part as what? 43%. So meaning that these 43 guys were counted twice. So meaning that they are appearing on internet and they are appearing on what? Cable. They are appearing in this. So because these guys who owned both of these items are appearing, we have to remove them because they have been counted twice. So therefore, that is why in the formula, when we say A plus B, we have to remove these guys that were counted twice because they are appearing in both counts. So therefore, that becomes the probability of A or B, all right, is equal to open brackets. We know that it is A, probability of A plus probability of B minus probability of A intersection what? B. Okay, and why we're saying A and B, it's because these were both. So I'll say 43 minus probability for A, it was 62. So I'll say 62 plus 62 plus 68. Are we together on this one?
Yes.
Okay, very good. So meaning that this will give us an answer of 0.87. And also something, maybe peradventure, maybe you have missed something, all right? Something that could also help you to know that you're reducing. So if assuming that you don't subtract, all right, that means you don't subtract, realize that the probability of these two will exceed 100%. Already meaning at that point, that should also give you a signal to say that something, I could be missing something here. So that could also be something that you could look out for. All right. Did you do contingency tables with Mr. Collins as well? Did you look at contingency tables? Hello?
I can't remember those.
Okay. All right. So with these ones, let me teach a bit, then we'll come back to, or then we'll answer the question after we could learn. Okay. So let me just share my different screen. I go to my whiteboard.
First, you were saying something?
Okay, so I'll just quickly run through contingency tables. Then after we have a basic understanding of that, then we'll go to the question that we have. So now, often we tell you the results of a survey in a two table and use the results of this study to determine various probabilities. We describe this idea on page, okay? In short, this particular representation where you already have results concerning a particular event, okay? So now the question is, how do those results have a bearance on each other? So a contingency table is used to classify sample observations according to two or more identifiable categories. Like for instance, I wanted to find out what is the probability that you are attending QM right now and you'll be going for work tomorrow, all right? Where I want to see how these two events tend to impact each other, all right? How are they going to affect the probabilities? Knowing well that the probability of you taking QM and also that you are going for work, they have their unique probabilities, but if I was to combine the two probabilities, what becomes the outcome? So that's what contingency table is all about. We are going to have two sides that are showing is two separate events. So now if you are to combine those activities, if you are to combine those events, the question is, what will be the outcome? All right, what will be the outcome? So a contingency table, it is a cross tabulation that simultaneously summarizes two variables of interest and their relationship. Just as I've noted, the level of measurement can be either nominal. So here we've got an example here of how a contingency table will look like, where on the left part you have a separate variable or communication, where in this case we are given a Facebook account, right? Where we are given a Facebook account. Then on the other side, we've got gender, all right? We've got gender where we're looking at men and women. So now a possible question would be, what is the probability that maybe an individual has 0 Facebook account and they are female in nature or vice versa? So those are the kind of questions that we'll be looking at. So where we look at things from two perspectives, okay? Is that clear so far? Or do we have at least a tangible idea of what we're dealing with contingency tables? Okay, so that is...
That's exactly.
Sorry?
No, I just wanted to support your explanation.
Okay.
So that's exactly what it is all about.
Yes, exactly that. So now that we've established that, let's attempt those questions now that we have in our tutorial guide. Okay, so we get back here. So now we have a contingency table. So as we made mention, we are looking at two variables, right? So on this side, we've got warm-up time, and this side we've got, let's say, wins. Then under wins, we have two sides where we've got Debbie or Deb and Bob. So the following data shows the total number of wins recorded by two friends playing tennis against each other. All right, against each other, based on the length of time they warmed up. All right, based on the length of time they warmed up before the match. So here we've got warm-up time it was short, long, then Debbie wins was 416 all the way to 20, 624. So now let me explain something before I make progress. So now there are certain times or certain points where the contingency table that you have maybe may not have the totals. Okay, where you have not been given the totals, you have only been given maybe the information as 4, 16, 6, and 24. So now in that case, the first thing that you do even before you attempt to solve the questions is to find the totals. All right, that's if the question doesn't have totals. You find the totals first, then you proceed in solving the questions. So that's just a pointer. Okay, so now that we already have our totals there, 10, 40, 50, 20, 30, and so on and so forth. So number one says, determine the probability, all right? Determine the probability that Deb wins the next match if she only has a short time to warm up. So now I've been given two things, eh? So saying that what is the probability, all right, that this particular individual called Deb wins the match, all right, if they win the match and that they had what? Short time, okay, and that they had what? A short time. So meaning that becomes your symbol. So probability that Deb wins the match and that they had what? A short time. So now we know to say that this particular row, in this case, represents the long time, all right? If they spent a lot of time warming up, okay? So now one of the easiest way to handle okay, right. So now, since we are looking at long time, so meaning that if the question has asked for short time, so meaning that the only area where I'll be focusing on is what? The time that deals with what? Short, okay? The part which deals with what? Short. So now, what is the chance that, at the same time I've been told that if Deb wins, so meaning that at no point am I considering anything that deals with what? Mr. Bob. Because the question is probability that Deb wins and the time is what? Short. All right? Probability that Deb wins and the time is what? Short. So meaning that the only places that I'll be focusing on, it is that and the places that have been left without the X there. Are we together? So now, the probability that Deb wins and that the time was what? Short. So what is the chance that Deb wins? Wins and short. It is the value of what? 4, right? Have we seen this? That Deb wins, right? And the
Yes.
time is what? Short. So meaning it's what? 4. Then we say the probability is always favorable outcome over what? Total outcome. Remember that's at the back of our mind, right? So now, if this is the
Yes.
occurrence, meaning out of the total outcome for all these chances, it's what? 50, right? Hello? So meaning that that becomes probability of D, all right, intersection S, which is what? Short, over the total, all right? Over what? The total, which is the probability of what? Short. So therefore, that becomes 4 out of 50. Are we together? So now since I'm looking at the probability of...
We can't see where you're computing.
Oh, yeah, anybody see my screen? Okay.
Yeah.
Okay, let me just reshare it. Are we able to see now?
It's loading.
Okay.
Okay, we can see it now. The computations we were just doing.
Okay, all right. Okay. So we start. So this will be given by probability. So we'll say probability, all right, probability of excuse me. Deb, and that the time was short, is equal to the probability of Deb, all right, Deb, and that the time is short. The time is short divided by the probability, all right, that the time was what? Short. So therefore, this becomes, what is the probability of Deb and that the time was short? We're saying that we're looking for what? The probability for this. How do you get the probability for that? We simply say probability for that is equal to what? 4. All right? We could say 4 over what? 50 for the first part, divided by, then here, what's the probability for short? Probability that the time was short is equal to what? So if we want to get the probability that whether it was for for Debbie or for Bob, we are getting for short. So meaning that I'm ignoring these two. So for short, it becomes what? 10 over what? 50. So by dividing that, I get my answer. Are we together? Are we together on this part? Then let me also show you another way of how. Sorry? Let me also show you another way of how you could arrive at this computation in the quickest possible way. All right? So now,
why didn't we get 4 over 20?
Why did we get, why did you not get
why
4?
we didn't get 4 over 20? Yeah, because I'm seeing the 50, it's a combination of the total for short and long. So if we are concentrating on the short and Debbie wins, so my thinking is for Debbie wins and the time was short is 4. So
Then
why are we picking 50, which is the total for everything, not
which is the total for
this
everything?
column for wins? Why are we not concentrating on the wins?
So you
Which
realize.
is
So one thing that you realize, if let's say I picked 20, okay, if I was picking 20 as my denominator as opposed to picking 50, you realize that I would also more like rephrase the same question as to saying why also including what? The long. But to answer the question as to why we're using 50, remember at the beginning we said that probability is equal to what? The favorable outcome over what? Total outcome. That's the picture, that's the formula that we're using. So what is the total outcome for this particular table? Is winding up to what? 50. And for the specific answer, that Deb wins. So what's the chance that the time was short and that Debbie wins? It's 4 out of 50. Because we're saying that it's the favorable outcome over the total outcome. So 20 is not the total outcome. 30 is neither the total outcome. Total outcome for what we have here is what? 50. Does that help? Does that help? We are just using the formula there. Is that okay?
Yes, it is.
Then I was explaining that there's a shortcut or another way of how you could arrive at the answer without using probability. So now, pay attention to the formula that I'm going to give you, all right? So now, the second formula of how you could do question number 1. I want to explain this because you would do 2, then we see how we progress from there. So now, the way I could do 1, if I don't want to use probabilities, all right? I'm saying probability of D, all right, given S, right, is simply equal to, I will say, D. So bear in mind that at the beginning, I have not used the probability. Okay, bear in mind, then. Over S divided by, I'll say, the for short. Have we seen this? So meaning that in this particular case, I'm not using probabilities. So from the table here, I'll simply go and say, what is D intersection S? Okay, what is D intersection S? D meaning Debbie intersection short time. They are meeting where? At 4, right? So I simply record my 4. All right, then S is representing what? The total for what? Short. So I could even maybe say total for short. Total for short, it's what? 10. You divide that. 4 divided by 10, you get what? 0.4, which was the same answer that you got when we used what? The respective probabilities. Is that okay? So the gist here is this sign. So here of the that wins the next match if she was. So now if it was like this, let us say it was like probability that the time is short and that Debbie wins. Okay, have we seen this? So now these two are not the same. Right, probability that the time is short and that Debbie wins. So now using this expression that I've shown you, so now this would be the way I wrote this. I started with the D. It came there, then the S came there. Then what becomes the denominator becomes the last figure there. So meaning in this case, this would be S intersection D over D. Are we good? So meaning in this case, I'll get what is S intersection D? I'm still getting 4, right? But at the bottom there, I'm getting 4, the Debbie wins, which will be what? Out of 20. With a shortcut that if you don't want to be using probabilities time and again, or you just be getting values the way they are. So, but just be careful the way you tell them. If you say probability and you get 4 without dividing over 50, that becomes wrong based on your narration here. So if you have to use 4, all right, without having to divide over 50, you don't include this P there. You just say D intersection S over S, which is 4 over 10. Okay, we go to part B.
So, sir, are you saying that instead of saying 4 over 50, we could also use this other formula?
Yes, you could simply go straight and just pick the values where you say, what is D intersection S? That's 4. What's S? The total for S, it's 10. 4 over 10, 0.4. You get the answer. It's another way of how you would approach it is. So
if we use this method, then we just shouldn't put the P for the probability. It should just be D intersection S over S without the P.
Without the PS, meaning that you're not getting the probabilities of D intersection S, but you're simply getting what is on D intersection S. That's what you're getting. You're not getting the probability of that.
Okay.
All right, so we go to part B, if that is clear. So now part B says, or number 2 says, assuming Debbie wins the last match. So I'll be showing you 2 methods at every point so that we could have a wider scope of how we could approach such questions. So now here it's saying that assuming Deb won the last match, all right? So we're looking at Deb won the last match. Determine the likelihood that the warm-up period before the match was what? Short. So now, what is the question here? We want to determine that the likelihood that the warm-up time was what? Short. Okay, and that determine the likelihood that the warm-up period before the match was what? Short. So meaning this would be probability, all right, that the time was what? Short, and that Debbie wins. Okay, so that is in one way. So that would be equal to, so you say now the probability of S, all right, short, and that Deb wins divided by the probability of what? Debbie winning, or Deb wins, right? So meaning that at this point, I have to find the probability of... Is that a question?
Mr.
Yes, please.
Yes, I thought we were. And the question says that Debbie won the match before giving us the hint that it was short.
I did not hear. I did not get the first part. What was the first part?
I'm saying I thought we were supposed to start with the item that was mentioned first, and then this question says that Debbie won the match before mentioning that it was in the short warm-up period. So I'm thinking we're supposed to start with probability of D, provided that it's short.
We do this. That's what you're saying.
Why are we starting with S?
Oh, okay.
Yes.
I get your question.
Because
Okay.
mentioning that Debbie won the match.
Okay, all right. Thanks. All right. Let me explain why we are doing it in this particular way, right? So now here say, assuming that Deb won the last match, right? Determine the probability, the likelihood that the warm-up period, right? The warm-up what? Period. So now what is signifying warm-up period? It's what? So what has been given first? Determine the likelihood that the warm-up period before the match was what? Short. So now, one key thing about contingency tables that you have to be aware of is learn to find where the question is, all right? And follow the question the way it is. So now, we are being told saying we have to, assuming that Deb won the last match. So we know that it's about Deb, right? This is the hint saying that, okay, we're still looking at what? Deb. So now, what are we doing with Deb exactly? What we're doing with Deb is that determine the likelihood that the warm-up, are we getting it? The warm-up. So what is suggesting the warm-up? So meaning that the warm-up period before the match was what? Short. So the warm-up period that it was what? Short. So meaning that based on where the question is starting from, we have been given the warm-up. So therefore, I'm starting with what? Short, which is signifying for what? Warm-up. And whose warm-up am I looking at? I'm looking at the warm-up for Deb or Debbie. Is that okay? So here, technically, what was mentioned first was what? The warm-up period. So meaning that this particular Deb, if, for instance, for argument's sake, let's say we removed this part. We removed this, and we removed this. Would you be able to answer this question? So meaning that
No.
Sorry? What's your, would you be able to answer this question? Assuming that Deb won the last match. There is not much information about it.
It's incomplete.
It's a statement, right? It's a statement. But where is the question in the statement? The question is now saying that, okay, determine that the likelihood that the warm-up period before the match was what? Short, and that Debbie won the last match. That's how you would read it another way, where now you pick. So the first letter in this context becomes, where is the question starting from? That becomes your first. Then your second is what you are looking for from a wider perspective. Is that okay? Hello? Is that okay?
Yes, it is.
Yes, sir.
Okay, all right. So now, meaning that for this particular point, we have to find, so remember we are saying that it's probability, it's favorable outcome over what? Over total, right? Favorable over total. So we don't forget that. So if I'm getting S intersection D, S intersection D, I've got short and I've got D. So that is 4. All right, that becomes what? 4. So if I'm looking at the value of 4, meaning that what am I getting? Okay, so meaning we're getting 4, right? Out of what? 50 for the top part divided by. What about probability for them? Remember that it's favorable over total outcome. So I'm getting for them. So meaning the Deb before wins are how many? We don't know if they are short or long, but the wins were what? 20. 20 out of what? The total was what? 50. So I'll say divided by 20 out of 50.